Hi, let's discuss about volume and surface area. So these two concepts, volume and surface area, are related to 3D. What is 3D? In order to find this volume or surface area, you require three dimensions, that is x direction, y direction, z direction. Okay? Now, comes your volume here. It is amount of space occupied within its boundary faces. Now go to surface area. So it is area of plate surface that bind this solid here. If you have solid like this, the area of plane surface, right? Like we at a time we take only two dimensions at a time, not three dimensions. So if it is this is solid, now only this one, this plate, outer surface, this plate and this plate, this plate, this plate, this plate is called area here. So it's inside this solid that is comes under volume, and just outer plate comes under surface area. It's like in 2D geometry, like perimeter. In 3D, that perimeter becomes here area, and the area in 2D becomes here volume. Understood? Now surface area can be divided into two parts, that is lateral surface area, total surface area. Normally, if you have any object like this, now it will have some curved surface. This is a curved surface. Okay, or lateral surface. So for this object, whatever is that is bounded by the outer areas, they are called as lateral surface area or curved surface area. And if you include top and bottom in addition to this lateral surface area, then it is called as total surface area. So for 3D, we require to find total surface area and curved surface area. Fine. So let me take an example of, say, on cuboid. The space inside this cuboid is called as volume, and just the outer surface, this face, and backside face, those faces are called as lateral surface area, like the curved surface area. And if you include top and bottom surface area, they are called as total surface area for cube. Okay, all 3D figures will try to derive this volume and lateral surface area and total surface area. Equations are formulas. Now let's find volume for cube and cuboid here. What is the difference between cube and cuboid is? The cube, all sides are same. That is, length is A, length, breadth, height, all are same. And here I have taken the value of A for length, breadth and height here. Whereas in cuboid, they are not same. That is, length, breadth and height, they are not. It is length is equal to, breadth is equal to, height is equal to. All are same here. Where here length is not equal to B, B is not equal to height. Okay. Let's find volume for cube. So in order to find volume, we'll go to approach for that followed in finding area here. What approach we followed in area finding area here? In order to find this area, we have taken this stick with length A and we will move towards this vertical direction up to A length, and this total area is nothing but A into A, which is equal to A square. So this is the area of single plate. Now in order to form this volume, we require one single plate here, one single plate at the bottom, whose area is A square here. This plate has to move vertically towards vertical direction up to A distance, similar to this area. Here this single line is moving towards height A. Here the plate, whole area of this plate is moving towards vertical direction of A distance. So now volume is equal to this area of this plate into height. What is the area of plate? We know that it is A square for cube, and height it has to move is nothing but A, which is equal to A cube for volume of cube. Fine. Now what is lateral surface area? What is lateral surface area? The curvature surface area of plates for towards this curved surface area. Okay. Now for this cube, this is involved, this is involved, this is involved, this is involved. That means only 4 plates are involved towards curvature. So one plate area is A square, one plate area is A square, A square, A square, A square. It is 4A square for towards this curved surface area, that is lateral surface area. If you include top and bottom, again you have two sides. So this area plate is A square, again this area plate is A square. So complete it is 6A square here for total surface area for cube. In order to find the diagonal in a cuboid, so normally, so this is from this edge to this edge, you require diagonal here. So directly we cannot do here. So what I will do is, first I will try to find diagonal for this line, that is this line. Now from here I will again make for this side and this side I will try to make diagonal, and this diagonal is diagonal for cube here. So what is the length for diagonal for this plate alone? A plus A, it is root 2A. So that is here it is root 2A and here it is A here. Okay, so again I apply Pythagoras theorem, it becomes okay root 2A, A square is root 2A square plus again A square root 2. This is equal to root 3A. So the procedure for finding diagonal like this: first find diagonal for area on surface area plate, then include your height h for your finding diagonal and apply Pythagoras here, you will get this diagonal of cube. So we will apply the same process in finding cuboid, then you can understand very easily. Okay, now in order to find here volume, what we have to find first is nothing but area of this plate, first plate, and that plate has to move towards h direction. What is the area of this plate? This is length and this is breadth. Area of this plate is L into B. So that is nothing but area of plate into height, which is equal to L into B into height, which is equal to LBH. LBH is the volume formula for cuboid. Now we have to find lateral surface area, that is the curvature area. So this plane and back side of one more plane and this plane, only these two plane into two times. So for this plane, area of this plane, this is length L and this is height h. So area of this plane is L into h, and towards back side it has one more area like this. So it is nothing but 2 into L h plus here it is B into h for this surface area. Again into two times it is 2 into BH. So if you take 2 and h common, it becomes 2L plus h into L plus 1. This is for lateral surface area for cuboid. Next, in order to find for total surface area, you have to include top and bottom surface area. So here top is nothing but this is length L, this is length B. So this area is nothing but L into B. So bottom you have one more like this. So it becomes 2LB. So if you add here, total surface area is equal to, so already lateral surface area plus top and bottom, it becomes 2 into LB plus BH plus HL. Fine. Now, in order to find this diagonal for this cuboid diagonal, what the procedure I have told you. First for this plate, bottom plate, first find diagonal for two dimensions. So that is this one. That is, if you write it here very clearly, it becomes L into B. This is diagonal for this. It becomes square root of L square plus B square. Now for this, you have to add this height. This is height h. So again, this is again and this is your diagonal proper diagonal, which is equal to square root of L square plus B square plus H square. So here diagonal is equal to square root of L square plus B square plus H square. This is the way you have to find out. Here they have given cube and cuboid. If for any shape, we'll do like this only. First, we'll find volume with the help of area of plate into height. Then for lateral surface area means we'll take only curved surface area. Now total means we will include top and bottom. For diagonal is for surface area we will find diagonal, and total diagonal is we will include this height and we will find this perpendicular distance, that gives you diagonal distance. Next we will find volume and surface area for right cylinder and right cone here. What is right cylinder? So which has equal curved surface, like this is boundary, and the top and bottom has circles here, and where the center of this circle is touching the center of circle, and this point, this is nothing but height between this circle to this circle. This is called as right circular cylinder. Okay. Now here, in order to find volume here, so volume here, as I told you again already, always first find area of this bottom plate. We know this is a circle. This is a circle. So obviously the circle area is nothing but pi r square here, parallel, and this plate has to move towards height h in order to get this volume. That is nothing but area of this bottom plate into height, which is equal to pi r square into h, which is equal to pi r square h. That is volume of cylinder here. Now try to find this lateral surface area, that is this one. So in order to find area for any three-dimensional figures, what we'll do is we'll cut it and we'll spread it like this. We have cylinder like this. In order to find its area, what we'll do, we'll cut it and we'll spread it like this. We'll spread it like this and we'll make it as a 3D, 2D plane so that it is easy to find curved surface area. So if I spread it like this, it becomes like this. It becomes like this. Now, as this circle was cut and it was spread from here to here, what is the perimeter of complete circle? It is 2 pi r. You know this. And this is height h. In order to find this area of this curved part, it is length into breadth, that is 2 pi r into h, which is equal to 2 pi r h. Okay, this is for later. Now if you want to find for total surface area, that is total surface area here. Fine. Now we have to include this top end and bottom end here. Already we have calculated for curved surface area, that is nothing but 2 pi r h plus this is 1 pi r square, this is 1 more pi r square, it is nothing but 2 pi r square. This is nothing but total surface area for right circular cylinder here. And always this height will make 90 degrees with radius r. Always remember this for right circular cylinder. Now let me apply same concept here. It is a cone. This is your cone here. Like at the bottom you have curved surface area, and this is, and all this curved surface area will merge at a point, single point here. So this is point here, and this is curved surface area. Okay. Here, if you see it properly, in order to find complete volume, what we know already, we formula for this curved surface area for cylinder. If you cut this curved surface area for cylinder into three equal parts, one part, two part, third part. So by third part of this volume of cylinder will give you volume of cone here. By diagram, it is very easy to look here. Okay. So here volume of cone is equal to 1 by third of what we have calculated here, because pi r square h only. How to find lateral surface area? Lateral surface area for the cone. Now again same procedure. If you have cone like this, in order to find it in two-dimensional, let's cut it at some place and just move it like this. Okay, that is, if you cut it like this, it becomes like an R. Now, as it is not a complete cylinder, if you cut it here, this is on the top of it. It is not cylinder, unlike here. So that's why it cannot spread completely for 2 pi r radius. So it will move to radius of pi r here. Okay. So there is in-depth discussion why it is pi r. If anyone is interested regarding this, I'll explain in your comment box. Okay. Now, what is the height? So now not this height you have to take it, because this height you have to take it here. Because when you cut it and spread it like this, L becomes your height, not this one. Okay, what is L here? This is, as I said already, for a cylinder, it is 90 degree here. So this is R, this is H. This L is equal to square root of R square plus H square. So now here, this L as a height you have to take it like this, R square plus H square. So lateral surface area equal length into breadth. Again it is pi r L, which is equal to pi r into square root of R square plus H square. This is for curved surface area. Now, what is total surface area here? Already we know for curved surface area, and bottom we have one circle. We have to include only that circle. On the top you don't have circle here, unlike cylinder. So for total surface area, the formula is pi r L plus pi r square. That's it. That's it for cone. Let's discuss about sphere here. What is sphere? Circle in 2 dimension, it becomes sphere in 3 dimension. What is circle? It is an equal distance from a fixed point in x direction and y direction. Now, whereas here sphere, it is constant distance from a fixed point in not only 2 dimension, in 3 dimensions. So that is x direction, y direction and z direction. It's like, imagine like a earth here, which is upward completely x direction, y direction, z direction. Again, an example is cricket ball, which has all the dimensions. It is upward complete space here. Okay. So how to find volume for the sphere here? So normally, as it is upward in the top, bottom, everywhere, it is very difficult to find out in a plane. So we use the concept of integration to find this. But logic I can tell you here, like you know this, again use same volume concept here. First take a plane, you know, for a circle, if you look any side, from this side, and inside, it looks like a circle. No, so take this plane of a circle like this at the bottom. What is the area of this plane? Pi r square. And move this pi r square towards r. It becomes pi r cube. So the basic formula is pi r cube. But it doesn't cover complete, it is not equal on all sides. It is not equal on all sides. That's why it becomes pi r cube plus 1/3 pi r cube, which is equal to 4/3 pi r cube, which can be again explained with the help of integrations here. So if you try to understand this, I'll explain you in the by using integration concept here. Now, what is the total surface area here? As I told you, from whatever side you look this sphere, it looks like a circle here. So from bottom one circle, from the top one circle, this side one circle, this side one circle. Total you have 4 circles here. So each circle will occupy pi r square here. So total surface area for sphere is 4 pi r square. Okay. Now if I cut this sphere into 2 equal halves, then it is called hemisphere. That is, half sphere is called as hemisphere. This is hemisphere. So on the top I have made a cut here and I have removed this, so it becomes like this, hemisphere. So one part is removed. So one part of this circle is removed. How many parts are remaining here? 3 parts. This right part, left part, bottom part. So that's why total surface area becomes 3 pi r square here. 3 pi. Here 4 pi r square, here 3 pi r square, because I made a cut on the top. Now, if I take it only curved surface area, so now I am not taking only taking bottom side now, only left and right. Left and right is nothing but 1 pi r square. 1 pi r square is 2 pi r square here. So as I made for total volume here, 4/3 pi r cube, I made divided by 2, and I made cut at the top. So it becomes 2/3 pi r cube here. Sorry, pi r cube here. Now, if I take all these formulas in single table, it looks like this: total surface area and volume for cube, cuboid, cylinder, cone, sphere, hemisphere. Now, if you observe it carefully, for cube, you require only one variable to find both surface area and volume. Here we require 3 variables here: L, B, H here. Here we require R value, that is radius, and height of the cylinder value to find both volume and area. Here we require 2 values again. So here R and H is required. Here also R and H is required for cone. For sphere, only one variable is required. Like only radius is required to find total surface area and volume. And there for hemisphere also, only R is required to find area and volume. Now the problems here, either can be direct substitution from problems here, or they say that if they have a cone with some volume and they want to make they want to melt it and they want to make some cylinders of some height h. What is that height h? Like that. As volume remains same here because it is melted and they made the cylinder. All the shapes. If they can melt this cube and they can make cuboid, and melt this cuboid they can make sphere. So volume remains same. And there may be one more problem like this: is a circular wire that is like this, circular wire. Okay, is made a cut and they made a square. So if this circular wire is made a cut and they divide it, it becomes a line like this. And this length of this line is equal to this 2 pi r, perimeter of circle. This is made again a square. This length wire is used to make a square. So this length of this one is equal to perimeter of a square, that is equal to 4a. Then like this you can make equation and you can find a value here. With the help of a value you can find area of square. So like this they can convert the volume, one volume to another volume, or one side perimeter to another side perimeter. We cannot do it conversion from area because area is a single plane that cannot be converted to again one more area. Only either we can convert this perimeters to perimeter or volumes to another volume. Okay. Next, one more type of problems we can see is if there is a percentage increase in length and there is a percentage increase in breadth. What is the percentage change in area? Like this question. Say for an example, if it is a rectangle whose lengths are L and B, there is 10% increase in length and 30% decrease in breadth. 10% increase in length, 30% decrease in breadth. What is the change happening? Its area. That's the question they will ask you. For the first find initial area, that is length into breadth without any changes. Okay. Now with the changed area, how this length has been changed, it got increased to 10%. So in order to write it like 10%, assume first initially we have 100, it is moved to 110. 110. So at present the change area is nothing but 110 L. Okay. Now in red there is a decrease in 30%. That is nothing but after decrease of 30%, 100 to 30. Initially assume it as a 100. After 30% decrease it becomes 70% B. So it is like now 110 L into 70% B. Understood? So first find initial and B. For changed, assume it as 100 and how much it is moving, 100 to 110. Okay, it is 110 by 100 here. Percentage, it is percentage means 70 by 100 it will be. Now try to find this value. It is 7700 divided by into LB. That is this zeros cancel. It becomes 77% LB here. Now initially it is only LB here. Now it became 0.77 LB here. If you convert this percentage, normally it becomes 0.77 LB. So here we have 1 LB. Now it moved to 0.77 LB. So what happened next? What happened? It got decreased. How much? 0.33%. That is 33 LB. That is equal to 33% decrease. So like these conclusions you can make. This is applicable for squares, areas, everywhere. So for sphere they will say the area value is 4 pi r square. Now r got increased with 10%. What is the change in area? Now initially take it as r as 100. Now new area is equal to 4 pi 110 is 110 by 100 r whole square. Because r got changed here with the 10%. Okay. Now it becomes 1.1. So 4 pi into 1.1 r whole square because 4 pi into 1.21 11 whole square is 1.1 r square. So this is initial, this is new, and now what is the change? Change happened is initial final minus initial, that is 4 pi r square 1.21 minus 1, it is equal to 0.21 4 pi r square, which is equal to what happened here? Initially you have 4 pi r square, now it is a change of 0.21, that is nothing but 0.21 by 100, which is equal to 21% change. So like that you can calculate and find the answer. So only the problem is this 3 types, that is either direct substitution value, second one is converting one volume to another volume or one perimeter to another perimeter, and third one is like this, there is a change of something here and what is this change happened in the net, like this. Try to understand the question very carefully. What is change happened and what the net change happened? There is a difference between this. Change is this one, just whatever with this modification. Net change is so initial minus final, or final minus initial, that is called net change here. If there is a minus, there is a decrement, you can tell that it is a decrease. If there is a plus, then it is an increase. Okay, try to solve all the problems on this. If you have any questions, you can post in the comment box. Thank you.
Please subscribe to my channel Connecting Minds and please share link with your friends. Jai Hind.